Today we're going to be looking at section 6.6. We are performing similarity transformations. The main thing we're going to discuss today is what's called a dilation. So I've got a lot of vocabulary here for you to take a look at. This first one here says a dilation is a transformation that stretches or shrinks a figure to create a similar figure. So the best example I can give you is a photograph. So if we had a 3.5 by 5 inch photograph, and we wanted to stretch that into a 5 by 7 photograph, everything would stretch proportionally. Okay, so the image would grow and it would not be blurry, it would be still visible. In a dilation, a figure is enlarged or reduced with respect to a fixed point called the center of dilation. So we're going to do a little bit on a coordinate plane. So the origin, or 0, 0, will primarily be our center. We've talked a lot about a scale factor. Scale factor of a dilation, it's the ratio of a side length of the image to the corresponding side length of the original. We'll come back to that here in a little bit. And then coordinate notation for a dilation right here. Coordinates are going to be x comma y, on a coordinate plane. So you can describe a dilation with respect to the origin with the notation. For any point x and y, it can be mapped onto any value of k times x and that same value of k times y. K is going to be the scale factor. So again, we will discuss that in more detail when we get to some examples. And then you can read that last part about the dilation being a reduction or an enlargement. Okay, so let's go ahead and work on this first example on the coordinate plane. We're going to draw a dilation of a quadrilateral ABCD with the following vertices, A, B, C, and D, and a scale factor of 3. So let's plot A, B, C, and D. So go ahead and start out by plotting your 4 ordered pairs. B is at 2, 3. C is at 3, 1. D is at 2, 0. So when you connect this, you will have a 4-sided shape. So if our scale factor is 3, so what that means is for every xy, when we run through the dilation, it's going to be 3 times x and 3 times y. So your new ordered pair will be the original x multiplied by 3, original x multiplied by 3 as well. So let's write out the 4 ordered pairs. So if I'm working with A, I'm going to write out all 4 of them here to start with, and then we'll go back and dilate each ordered pair. Okay, so if I'm going to go ahead and do the dilation, when I run it through a factor of 3, my new value, and I'm just going to call my new shape P, Q, R, and S. So my value of P is going to be 0 still, because 0 times 3 is 3, and then 9. And then if I run B through the dilation, I'm going to do 2 times 3, so I'll get 6. 3 times 3 is going to be 9. So you're just multiplying everything by a scale factor of 3. So R, I'm going to multiply each by 3, it would be 9 comma 3. And then the last one is going to be S, so that would be 6 comma 0. So if I were to plot this, we can see that it has grown by a factor of 3. So 0, 9 is going to be right here. 6, 9, 1, 2, 3, 4, 5, 6, 9. R is at 9, 3. And then S is at 6, 0. So my new shape is going to be right here. So that is a dilation of 3. So this is coordinate notation. Coordinate notation is simply writing the original to the new mount. Okay, so I would like you to go ahead and do number 1 here. And if you would go ahead and pause the video while you do that, I'd like you to pause it while you work, and then you can come back and check your answer. Okay, if I were to graph this, first of all, I would have P is at 5, 0. Q is at 5, 5. R is at 10, 10. And then if my dilation is for every xy, my scale factor is 1/5. So I'm going to multiply each by 1/5. So P is 5, 0. Q is 5, 5. And R is 10, 10. So if I were to run those through the mapping, and I called my new one ABC, I would get a 1, 0. I would get a 1, 1, and then I would get a 2, 2. So 1, 0, 1, 1, and then 2, 2. So that's going to be a real tiny shape. Okay, so that's what dilation looks like on a coordinate plane. All right, we are going to also look at enlarging and reducing, like I used the example of photographs and other drawings. So this example says that a digital photograph has the height shown in the diagram. You want to reduce the size of the photograph to the height shown. What is the scale factor of the reduction? So I'm going to write a definition here. So when we write our scale factor out, it is going to be the ratio of a side length of the reduced photo to the side length of the original. So my ratio is going to be the reduced photo over the original. So if I look for my corresponding sides, I've got my 3 inches can be ratioed with 8.5 inches. And so when you go ahead and simplify that, that gives me a scale factor of 6/17. Okay, so you can either type that into your calculator, you can multiply both by 10 to move that decimal over. So if you did that, you would be reducing 30/85, and then that would give you your scale factor. Okay, so that's just a basic scale factor. Let me check my time here. Okay. All right, let's continue on. Okay, so we are going to go back to a coordinate plane, and we want to create a quadrilateral ABCD that is similar to quadrilateral FGHJ. And I'm missing a coordinate. So I want to find the coordinates of D. So first of all, I have to determine if this is even a dilation. So determine if dilation. Okay, and so I need to double check what is my scale factor. So I'm going to go back to this coordinate notation. I need to figure out what is K, what is my scale factor. So if I go ahead and start to list out my ordered pairs, F is at -1, 0. Okay, and so F corresponds to point A, and if I look at the graph, A is at -4, 0. So if I look at what is my scale factor, what did 1 get multiplied by to make it say -4? So it got multiplied by 4. And so does that work on the other one? Can I do 0 times 4? Does that equal 0? Yeah, it does. So K is equal to 4 in this case. So I need to see, is it 4 all the way down the line? So G is at 1, -1. That is compared to B, which is at 4, -4. So let's do the same thing. What is K? So +1 times what gives me 4? Well, then that's also going to be 4. Let's check it out here. Is -1 times 4 -4? Yeah, so that works out as well. And so H. So it's looking like 4 is going to be our answer. Let's double check that it actually works all the way down. So H is at 0, -3. C is at 0, -12. So if I do 0 times 4, I get 0. And if I do -3 times 4, I do get 12. So it looks like that is our scale factor. So if we know that point J, by looking at the diagram, is at -2, -4, all I need to do is multiply by 4. So my new point for D is going to be, I'm just going to multiply each of these by 4. So I'm going to have a -8 and a -16. So that is my fourth point. If it wasn't a dilation, I would not be able to go through and actually determine that. Okay, I'd like you to wrap up number 4 and number 5 on your own. So if you would pause the video and then come back and go ahead and double check your answer. Okay, on number 4, we are going to ratio the smaller or the reduced amount, 2.5 over 7.5, which gives us a scale factor of 1/3. Okay, so that's what we're going to have on number 4. And then on number 5, when you go through and line up all of your ordered points, your scale factor is going to be a 2. Okay, and so using that, we are going to be able to take J and figure out what D is. So J is 3,1. So that means D is going to be 6,2. And K from the diagram is 1,6. That means E is going to be 2,12. So these are the two we were looking for. Okay. For the assignment, if you would go ahead and jot this down and work through this, and then we can go through any questions that we have tomorrow.